Hello and good morning. My name is Akshat, and my question is: in generating a single sideband modulated signal, we phase shift the Hilbert transform of the true by pi by 2 and add it to the true signal to generate the complex baseband signal that has a single sideband. Explain what will happen when we are unable to achieve an exact phase shift of pi by 2. So, my question is here: कि, uh, in this equation we are multiplying j by m hat t. This means we are phase shifting the m hat t by pi by 2. But our question is, what will happen if we could not if we could not phase shift our m hat t, that is the Hilbert transform of mt, exactly by pi by 2. So let us suppose that we could shift this m hat t by theta. So our this equation will looks like here, where m tilde t is equal to half mt plus e to the power j theta into m hat t, where we are phase shifting this m hat t by theta instead of pi by 2. So this is a general case where m hat t is the uh, Hilbert transform of mt, where Hilbert function ht is equal to 1 over pi by 1 upon pi t. Like, if we take the Fourier transform of this equation 1, so this will look like equation 3, where mf is the Fourier transform of this mt and m hat f is the Fourier transform of this m hat t, uh, and m hat t is basically the Hilbert transform of mt. So we can represent m hat f as hf into mf, where hf is the Fourier transform of Hilbert function, which is this one. So our equation will look like this. Now, now if we substitute equation A, that is the Fourier transform of Hilbert function, Hilbert transform of mt, into equation 3, we will now get this equation, where m tilde f is equal to half mf plus e to the power j theta into hf into mf, where hf is the Fourier transform of Hilbert function, that is one of Fourier transform of 1 over pi t. Okay, and now we use something which we know, that is the Fourier transform of this hf is here, like it is equal to j for negative frequency and equal to 0 for zero frequency and minus j for greater than zero frequency. This is nothing but we can represent this as this one. Um, uh, like for f is less than 0, we can represent j by e to the power j pi by 2. For f is equal to 0, we can represent this by 0, and for f is greater than 0, we can represent this by e to the power minus j pi by 2. So after substituting the value of hf into this equation here, right here, we get this. We can transform this mf here into this form. So for f is less than 0, we are now have this equation. For f is equal to 0, we are now have mf by 2, and for f is greater than 0, we are now have mf by 2 1 plus e to the power j theta into e to the power minus j pi by 2. Like here is a plot of magnitude of 1 plus e to the power j theta into e to the power j pi by 2 with theta. And here we notice something like near pi by 2, or we can or insert in exactly at pi by 2, our function, which is the mod of 1 plus e to the power j theta e to the power j pi by 2, vanish around pi by 2, like not vanish around pi by 2, but at pi by 2 it will vanish. So at theta is equal exact whenever our theta is equal to pi by 2, this negative component of frequency will vanish because this value becomes 0 near pi by 2, or exactly at pi by 2 this value will become 0. So our function will be like 0 for f is less than 0, mf by 2 for f is equal to 0, and for f is greater than 0, this value become 2. So that is equal to mf. But our question is, if we could not get exact phase shift of pi by 2, what will happen? So if we could not get exact phase shift of pi by 2, this means we have some delta plus minus with pi by 2. So uh, so if we substitute pi by 2 plus delta, if delta tends to 0, or like suppose delta is some angle, so that value is not equal to 0. Like for theta equal to pi by 2 plus delta, and delta is not equal to 0, our function will not be 0. Our function means this function, like 1 plus e to the power j theta into e to the power j pi by 2 will not be 0. This means this means that for f is less than 0, our function will not vanish. This function will not vanish. This means that we could not completely compress our negative frequencies. This means we could not get exactly single sideband what we need or what we wanted to. And this function will vanish for theta is equal to pi by 2, and also we can generalize this form as theta is equal for theta equal to 2n pi plus pi by 2, where n belongs to 1 minus infinity to infinity, and n is an integer. So for this angle, for theta equal to 2n pi plus pi by 2, this function will become 0. I think this is of no use, but okay. So at theta equal to pi by 2, like for theta equal to pi by 2, or in general 2n pi plus pi by 2, our m tilde f is equal to 0 for f is less than 0. But we have a question, like my question was that if we could not get theta exactly equal to pi by 2, then what will happen? So this will happen means if our theta is not exactly equal to pi by 2, then our m tilde function will not become 0 for f is less than 0. And I told the reason here, because our for pi by 2 plus delta, this function will not vanish. This function will not vanish, so negative frequency component will not vanish. And I have represented this graphically here, like uh, this is our original modulating signal, which is mf, and this is frequency response of mf, and this is a single sideband modulated signal. If we are able to get the phase shift of pi by 2 exactly, mm, yeah, pi by 2. But if we could not get exactly the phase shift of pi by 2, then this is then our single sideband modulated will not be ideal. That will contain some negative component, like some non-zero value for f is less than 0. So this will happen, and this is the answer to my question. Okay, for if we could not get exactly phase shift of pi by 2, then we could not get an ideal, or we will not get an ideal single sideband modulated signal. Instead of that, we will get this thing where we have some negative part and also we have positive part. And now I'm in whole my lecture I have talked only about upper sideband. You can easily calculate all these for negative sideband. And at the end, I just want to show something. Like suppose this is MF. This is the frequency response of our signal. After taking Hilbert transform is nothing but we are rotating the negative frequency component by plus pi by 2. Means If this is my MF, then this will rotate by plus pi by 2. So this will become JMF. And for negative frequency, our our result become minus JMF. Basically, we are rotating this by minus 90 degree here, minus 90 degree. So this will become this. And after phase shifting by pi by 2, so this is a Hilbert transform of this MF. So if we take phase shift of plus pi by 2 on both of these, then our this function will become like, if we take plus pi by 2 phase shift, this will rotate as its original position. So this will become this. And if we phase shift this by pi by 2, this will become exactly equal to minus MF. And if we add this to the original function, which is MF, so we will get 2MF and here 0. So basically for F is greater than 0 or positive frequency, we will get 2MF, but for negative frequency, we will get 0. And this is the ideal case, like for theta equal to pi by 2. So this is a like a graphical representation of what we are doing during conversion of MF, or during conversion of signal into uh, during conversion of a signal into single sideband modulated signal. Yeah. Okay. Thank you.